So we just went over how to graph a parabola. So first we found our zeros, then we found our axis of symmetry by just looking at what's in between the zeros. Then we used the axis of symmetry and plugged it back into the equation to be able to find our vertex, which is 1, negative 9. And then we went back up and decided that we needed to find negative 8 by multiplying negative 4 times 2 is negative 8, and that was our y-intercept. And we used symmetry to find the point on the other side, axis of symmetry, and then we graphed it. Okay. I don't think we need to do another one. I think we just need to practice today. Okay? So if you need help with that, you should go back and rewatch the video, right? If you need help with graphing parabolas, or you should come after school. I'll be here today after school. Yay. Okay. This one, what would I do with it? First, we know the y-intercept. We have 1, 2, 3, 4. Right? Before you subtract the 4 and complete the square, you should probably check to see if it's factorable. 2 and 2, right? It doesn't require, right? It's not going to require completing the square. You should always check first. Does that work? It's factorable. Okay, so now we can do the same thing with this one too. We know what our zeros are. If they're both the same, if my zeros are both negative 2, 0, what does that tell me? It's a double root. What do double roots do? They bounce back up. And there's also, it means that's my axis of symmetry, and it's also my vertex. Right? Like this one's a done deal. Whoops. Vertex is negative 2, 0. You don't need okay, so what is a restriction? But what do we use restrictions for? To cut a graph, right? Are we cutting a graph in half right now? No. This one, I'm not going to have 5 points, but there's a reason for it, right? I could find another point by substituting back in. So I know that there's going to be another point here, right? Somewhere up here. So I should just substitute in 1, 2, 3. If I put 3 back into the equation, 3 squared plus 4 times 3 plus 4 gives me 9 plus 12 plus 4, way off the graph. Did I do that right? Yeah. No, it's not 3. It's over 3. It's 1. Ugh. I'm so off today. 4 plus 4. I could plug it into either one, right? So if I put in 1, I get 9. So then there's my 5 points. Yeah, I want 5 points. We're talking precision now, right? We need to be able to graph. Be prepared to do this as well. Yes. I want you to use 5. Yes. Could I just use what? Yes, absolutely. Because 325 is not on the graph. But it doesn't help you graph it, so no. Does it make sense? It's another point, so you would be correct, but since it's not anywhere near the graph, you only use 5 points to help you graph. Make sense? Did you guys hear Kane's question? It was an awesome one, and I didn't even think about it. Yeah, he said you could have used the magic numbers, those squares. So from here, I would go over 1 up 1, over 2 up 4, over 1 up 1, over 2 up 4. You can use that too. There's your 5 points right there. Good job. Fantastic. You know what? You know why that was, that I didn't catch that? Because I'm looking like this, tunnel vision, like, oh, they just need to know this. There's lots of ways to do things. Okay? Fantastic. Thank you. All right, so I think Miss Wiz, this is what she went over with you. She made you a nice, pretty poster, right? So it's easy when y is all by, when you only got one y, right? But when you've got quadratics, it gets a little bit more complicated, correct? Okay, we have to complete the square. And then if any of you went and looked ahead, you also, you're going to have fractions also, so it's going to get a little bit more complicated. So we're going to work on that today. Okay? Yes. It won't be the most difficult ones. There's some that are really difficult. I wouldn't put those on the quiz, but before we leave, I'll let you know. Okay? Yeah. It's individual. Okay. So what type of shape is this? This is quadratic, right? So what type of shape is it going to be? What type of shape is the inverse going to be? It's not cubic. It's, what's the inverse of a square? A square root. It's going to be a square root function, right? That's what it's going to look like. So the best way to do this is we're going to switch x and y. So we've got y equals x squared plus 4x plus 3. I'm going to switch x and y. So now I have x equals y squared plus 4y plus 3. Now what do? Subtract the 3, the other side. So now I have x minus 3 equals y squared plus 4y. We have to complete the square. So what makes this a perfect square? 2 squared, which is 4. 2 squared. And so since I added something to that side, it's uneven. So I have to add to the other side as well. So now we're left with x plus 1 equals y plus 2 squared. And we need to square root it. And I'm left with let's do this. Now I have the square root of x plus 1 equals y plus 2, and I'm going to subtract the 2 from the other side. So my inverse function is the square root of x plus 1 minus 2, and that's what you guys did yesterday. So now we've got that on recording. Okay? Now, could I have done that a different way? Could I have found the inverse another way? I could have transposed the points. So if this is negative 2, negative 1, so I want negative 1, negative 2. If this point is negative 1, 0, I want 0, negative 1. And if this point is 0, 1, 2, 3, then I want 3, 0. Now, I like doing that, and this is why. Now, you can certainly graph it like that. That is totally fine. But you need to be able to do this as well, because I will test you on whether you can do this as well. Now, the beauty of it is that now you have an answer key. It's like checking your work, right? let's make sure you did this right. So this means I would go left 1, down 2. Left 1, down 2, is that right? And then I know my magic numbers are over 1, up 1, and over 4, up 2. So is it graphed correctly? So now I know for sure that that inverse function is correct. Okay, lots of hands. I think Aaron was first. Okay, let's hear it. I don't understand the question. If you started with the green one and you're graphing and you want to get to the blue, you can also switch the points to do that, transpose the points, and you would have this, and you would still switch X and Y, right? Yes. So you can go back and forth. Good question. Yes, Andrew. Transposing points. So these points right here, Andrew, this is -2, -1. In order to get the inverse, you just switch the points. So just like we switch X and Y to get the inverse function here, you can do that with the points too. You can just switch the points, X and Y transpose. Yep. Yes. Yeah, this is, yeah. You mean go from here to here? That's fine. I wouldn't skip steps though. Okay, let's hear it. I'll tell you. I'll look at it and I'll let you know. Yes. You know I never do that. What else? Right? Do I ever say something's completely wrong? You're going to get partial credit, yes. Any other questions? Are you sure? Malik? Yeah, you have to show work. There is tutoring today. It's necessary. You're right, it's not necessary, but it's necessary to get full credit. Because Malik's saying he can graph it, and then he can just tell me what that function is by looking at the graph. And he's right, he can. But I'm going to test whether or not you can do this. Yes. Trinity. Well, I know, right? I can do it a few different ways, Trinity. I can just, you should know how to graph that, right? Yes. You should know how to graph this, right? This is a horizontal shift to the left one, and this is a vertical shift down 2. Yeah. The magic numbers. So the magic numbers come from if I put 1 in and I take the square root of it, I get 1. If I put 4 in, I get 2. That's where I'm getting those numbers from. So I go, if I put 1 in, I get 1. If I put 4 in, I get 2. That's where those are coming from. Good question. If there's, exactly, let's not, okay. All right, so Catherine, you see how this one is, oh no, it's still the same thing. All right, I was going to going to say it's going the other way. When the graph is blank. Yes, I understand. I'm looking for them. I don't think I have them in here. If the graph isn't there, you should still be able to graph, right? You should still be able to graph a parabola given this, correct? Okay. A minute there, I didn't even see where it was going. Okay. So when you don't, so for this one, this is a perfect square trinomial. I can see it already, right? Because if I take half of 6, that's 3, and 3 squared is 9. It's already a complete square, right? So I can graph this first. So this is over 3, and then over 1, up 1, over 2, up 4. That's where that comes from. Okay. This one's nice because I can even, at this point, switch x and y because it's already a complete square. Correct? It's like all my work's done for me already. So now it's x equals y plus 3 squared. Take the square root of both sides. No. It's the same. Yeah. Yeah. Okay. So now I have the square root of x equals y plus 3. The square root of x minus 3 equals y. I don't want to spend a whole lot of time on this because I want to get to the new learning. Okay, so if we're still having a hard time, you need to come to tutoring. I always try and see if that's factorable. You should always try and factor it. And when I went to factor it, in my head, I said, well, half of 6 is 3. 3 squared is 9. It's already a perfect square. 3 and 3. You could, I'm a mathematician, so I see it. I don't expect you guys to be able to do that, but you should be able to do this. I mean, some of you can do that. How many of you did that? Said, oh, that's a perfect square. There's a few people in the room that can do that, okay? So I say 3 and 3, and x, and plus, oh, it is a perfect square trinomial. No, I can. Okay, you should get to that point. It would be nice. It's faster. It's just another tool in your toolkit, correct? Just like Kane came up with, why can't I just do the magic numbers, right? He saw it, and I was sitting there trying to graph it with all that stuff. Okay? Alrighty. Let's look at this one now. Okay, so we know it's a rational function. So its shape, if I didn't have it graphed already, we know it's rational because we have a fraction, right? We know x is in the denominator. We know that it's shifted over to the left 3, correct? If I put this in a different form, it'd be y equals, what's my a? A is 1 times 1 over x plus 3, and then what's my other shift? Plus 0 is no shift, up or down. All right, so now I'm going to switch x and y. So I have x equals 1 over y plus 3. Everybody agree? Okay, I'm going to show you a trick, but it's not really a trick. Ready? Check this out. Does everybody agree that 2 over 4 is equal to 8 over 16? Everybody agree with that? So what if I did this? What if I took the inverse of this side? I would have to, in order for this to still be equal, I would have to take the inverse of the other side too. So is it still equal? Yes. So that's a nice, easy way to switch this. Okay? So it's going to be, so this is x over 1, right? So I'm going to switch this, take the inverse, which is 1 over x. No. Move. Okay. So this is going to be 1 over x equals y plus 3. Correct? And now I just have to move the 3 over, subtract the 3. Right? Because this would be y over 3 over 1? Y plus 3 over 1? Now these are the easy ones. So now I'm going to have, move this down too. I don't want to skip any steps. So now I'm going to erase this because I don't need it. And subtract the 3. So I have 1 over x minus 3 equals y. So my inverse function is 1 over x minus 3. So instead of having a horizontal shift, it's going to have a vertical shift. So I'm going to have an asymptote at down 3. 1, 2, 3. These are harder to see the reflection because there's so much going on with them. Correct? And then I don't have a horizontal shift. So there's my asymptotes here. So I start here at my vertex and I don't have a stretch. So I'm just going to go over 1 up 1. And there's my inverse. Is this going to be on the quiz tomorrow? Let me take a look first, okay? Malik. Were you watching? How'd I get 1 over x? So you agree that 2 over 4 is equal to 8 over 16? I took the inverse of both sides. Why? Why? Just take the inverse of both sides. It's easier, isn't it? Do you guys understand what Malik's asking? He's trying to do it the traditional way, and I found a Kane way to do it. Right? You're trying to do it traditionally. And I'm trying to show you that you don't have to always do everything traditionally. As long as you're doing it mathematically correct, this is what he's talking about. Place in another one. Let's start here. If you have this, I believe what you're talking about, Malik, is that I should multiply both sides by y plus 3. True? Correct? And then I would have y plus 3 times x equals 1. And then I would divide both sides by x. But this is really how you were taught to do it in Algebra 1. And then you would subtract 3 from both sides, and you would get y is 1 over x minus 3. It's the same thing, just less work. I just decided, you know what, I'm just going to take the inverse of both sides, and then it's easier. Essence. Isn't y plus 3 over 1 y plus 3? You're correct. Y plus 3 over 1 is y plus 3. Yeah. Go back. We're here. You see it? You got it? Good. Malik? No. It's going to work for problems that look like that, where it's going to work for problems that look like this. I'm going to show you the ones where it's not going to work for right now. Yes. That's just like this one. It makes the asymptote go down 3. Remember? Questions? More questions? We really need to get through the next one so you guys can just work on this, because the next one's a hard one. You ready? The next one, you guys are going to be like, there's only 2 on the homework. I'm going to do one. You're going to do the other one. Okay? And then I'm going to check and make sure it's not on the quiz. Because, okay, so here's the difference. This is the hardest one. Okay? Do you guys see how it's different from the one we just did? How is it different? I have an x over an x. So if I take the inverse of both sides, it doesn't matter. It's not going to get me anywhere. Does that make sense? The reason I did the last one was because if I had a 1 over x plus 6, if I take the inverse, I got rid of the fraction. Does that make sense? Okay. So let's do one of these. All right. So I'm going to do 8. You guys are going to do 10. Or you want me to do it the other way around? You want me to do 10? Okay. Okay, so we have y equals x plus 1 over x minus 1. I'm going to switch the x and the y's. So this is going to be x equals y plus 1 over y minus 1. If I take the inverse of both sides, it's not going to make this problem any easier because I'm still going to have a y in the denominator. So there's no reason to do it. All right, so now I have to go that traditional route, like Malik was doing, and I've got to multiply both sides by y minus 1. So that's what I'm going to do. I'm going to multiply this side by y minus 1, and I'm going to multiply this side by y minus 1. That gets rid of my fraction. So this goes away, and I'm left with x times y minus 1 equals y plus 1. How am I going to get y all by itself? What? Divide by 1? I still have a y on this side. So how can you just change a sign? What? You can't add it. It's being multiplied. You can't divide it because then we're right back to where we were. How are you going to square root it? That's not going to do anything. That's not, you've got to, okay. So let's try that. Wait, I'm getting lost now. Well, I know, but I'm lost. Yeah, get all the y's on one side. I'm stuck. This is why I wouldn't put it on a quiz, because I'm stumped. I hate these.
What if we had that problem? Let me change these twice. Okay.
Bryce, be quiet.
What if I gave you that problem? That's algebra 1. What would you guys do to get the Bryce? Bryce, I want you to answer this one because you've given us. Okay, how do we solve this? It's algebra 1 problem. Oh, you get all the y's on the same side, right? That's exactly what you do there.
Thank you, Miss Liz. I really appreciate it. I was stuck. See, that's exactly why I wouldn't. These are hard, right? Well, we're not done. Bryce, stop closing your mind, okay? I just told you it's not on the quiz, so stop complaining about the quiz, okay? Thank you. All right. So just like Miss Wiz did on the Algebra 1 problem, I love it, structure. If I want to get the y by itself, right, we're going to have to get the y's all on one side. Correct? So now I have xy minus x minus y equals 1. Now I'm going to add the x to the other side. Yeah? Mama likes this, huh? It's like a puzzle. She's good at this. So I'm going to add x to both. Bryce? Shush. So I'm going to add x to the other side, and I have xy minus y equals 1 plus x. Correct? Now what can I do? I'm going to factor out a y, and I get x minus 1 equals 1 plus x. Now how can I get y by itself? Divide by x minus 1. I didn't say you were going to like it. It's a lot of steps. It's a puzzle, right? It's a puzzle. 1 plus x over x minus 1, and that's your answer. Guys, stop complaining. I don't want to hear it. Okay? Thank you. No, it's complaining. That's all I'm hearing is complaining. Yes, Malik. I'm sorry? No, they're not all going to be like that, okay? Yeah. Okay, we'll do this one, and it's not going to be the same. Yes. I can't. No. You don't have the same thing I have. That's not the same thing. Oh, you want to divide it, and then you came up with, God. No, but it's because you're getting the same thing. That's not going to work with the other problems. You're just, okay. It's not going to work. It's because it's a reflection of itself. That's why that works right now. But it's not going to always work like that. This one. That's one that, you guys try it. Try the same steps I did. What did I do? You guys need to try. Don't just look at it and go, I can't. I need you to try. So get your homework out and start it. Number 8. Start number 8. I need you guys to try. If I sit up here and do it for you, that's not going to help you to be able to do this. Okay? I'm not doing well with all the complaining today. Yeah. Okay, I'm going to pause it, and you guys are going to try and work on it. Okay? I think I can. Instead of, wah, I don't like this. This isn't fun. Okay? Okay, so I'm going to have y equals x over x plus 5. Now I'm going to switch my x and y's. I'm talking, guys, so why do I hear all the talking? X equals y over y plus 5. Are you saying in this step that you divide? Here? Yeah, that'll work. Once you switch x and y, you could divide. That's not, I didn't understand what you were saying. I thought you were talking about from here, you divided. Okay, so now I have, do you guys understand what Monique's saying? So does it still work? You can't divide. I'm trying to think, does dividing make y by itself? I see how he did it. Okay. I'm just going to keep going. All right, so I did the same thing as I did over here, correct? So what did I do to this side now? How did I get rid of this y minus 1? I multiplied both sides by y minus 1, so that means what am I going to do with this one? I'm going to multiply by y plus 5. Correct? And that means this go away. And now we're left with x times y plus 5 equals y. So I've got y on this side and a y on this side, and I'm trying to solve for y. So what do? I'm going to move it to the other side, right? Okay. I'm also going to distribute this. Okay? So I have xy plus 5x minus y equals nothing on that side now. So now I have y here and a y here, and then I have a 5x here. I can't factor out a y with that 5x here, so what am I going to do with it? Move it to the other side. So I have xy minus y equals, it's now negative 5x. Why can't I what? I can't factor out a y from here because this one doesn't have a y. Does it make sense? So since it doesn't have a y, I need to move it. And I understand that this is the most confusing part of this, right? Okay, and so now I take a y out, and I'm left with x minus 1 equals negative 5x. And now I'm going to divide both sides by x minus 1 to get y all by itself. It's not the fact, it's tedious, right? And this part right here, this gets a little bit, like, sometimes you might feel like it's a little bit stuck. And so now I'm left with y equals negative 5x over x minus 1. It's not rational yet. I mean, it is rational, but you couldn't graph it like this. How would you convert a graphing form? When you have x's on top and the bottom, you divide. You would divide. Now that I've got x's on one side, I would divide. I would divide negative 5x divided by x minus 1. X goes into negative 5x how many times? Negative 5. Negative 5 times negative 1 is positive 5. Negative 5 times x is negative 5x. What's my famous phrase? Draw the line and change the sign. So I'm left with a negative 5. And so I have, this one's actually easier. I have a negative 5 out of, this is my remainder, right, even though they're the same. This is my remainder, so it goes in the numerator, and it's out of x minus 1, and this negative 5 goes out here. That's how I would graph it. Okay? That's the actual answer. But these you didn't have to graph, right, on the back. Hold on, I've got 3 people asking me questions at one time. Essence. I wouldn't make, that's like a challenge problem. That's a lot of work, right? Yeah, exactly. Yep, keep it right here. That's enough to tell me what the inverse is right there. Okay? So Malik, you're telling me that from that step when you transposed x and y, when you divided, you got this? Which would still be correct? Yes. Good question. Okay. So you need to be able to tell me what the equation is by looking at the graph. You need to be able to graph square root functions. You need to be able to find the inverse and graph. It looks like a line, a quadratic, and a cubic. So that means you got to be able to do these right here. They look just like this. Except you won't have this graph for you. So your problems on your homework are like number 2 and number 4. You've got to be able to do that. There's 3 of them. Oh, that's just the front side. And then you've got to know about stretches, vertical stretches and horizontal stretches. There's questions about those. There's a word problem. Can I see the word problems for these? Oh, perfect. This one right here. So number 11 on your homework. Number 11 says the volume of a sphere can be modeled by V equals 4/3 pi r cubed. Solve for r. How do we solve for r? I want to get r all by itself. Hold on. First it says this. It says solve for r. So I'm solving for r. Take the cube root. I'm going to take the inverse of 4/3. We don't want to cube it until that's all by itself. So we take the inverse of 4/3, which is 3/4. Right? So that goes away. So now I have V times 3/4 equal pi r cubed. Now what? Divide by pi. Get rid of the pi. Right? Now I'm going to take cube it. You see that essence? I don't want to cube it until it's all by itself. Or cube root it, I should say. Because pi over pi is 1. Now the second part of that is find the radius if the volume is 36. So all I would do on that one, if I know this is what I already had, I had this. Volume equals 4/3 pi r cubed. So I know the volume is 36, so it's this. It told me. It told me in the problem. So what would I do with that one? The same stuff, right? I could have done it from this one. I could have found the radius by plugging in the volume there. If this is 36, it'd be 36 times 3/4 divided by pi, and then take the cube root of it. That's how you would find it. Yep, it'll be on School Loop. This is the answer to solving for r. Then I asked you what's the radius if the volume's 36. So I substituted in 36. I would put 36 in the calculator, multiply it by 3/4, divide by pi, and then take the cube root, and you'll have an answer. I can't. What? It's not a bonus. What? You could leave it like that. There's there's a word problem like this on the quiz. This one. It's done. Right here, this step is now v times 3/4 over pi cube root equals r. That's the answer. I decided to solve for r. It said solve for r. R is all by itself now. Does that make sense? I can't look at it anymore because I got to prepare for this other class. But come by for tutoring, we can look at it, okay? Awesome. I don't have time to do that right now. Can you come by right after school and we can look at it? Are you coming to tutoring today? Awesome. Awesome. Thank you. I appreciate it.